Hello, so in this video we will cover second part of the first unit, motion. So let's start our video with speed. Let's consider 2 points A and B at a distance of 100 meter apart. And now we are considering two trolleys X and Y. Let's say trolley X cover this 100-meter distance in 10 seconds and trolley Y cover this 100-meter distance in 15 seconds. So generally we can say if trolley X is taking less time to cover the distance 100 meter, that is same distance as being covered by Y. So we can say speed of the trolley X is more than the speed of the Y. So if we want to measure speed, then which two measurements we need? We need these two measurements, total distance traveled between 2 points and the total time taken to travel between 2 points. So speed is defined as distance traveled by an object per unit time. But practically, when we see, let's say you are going to your school from your home. So, do you think your vehicle, whether you are going in school bus or you are going by your own vehicle, do you think that vehicle is moving at the same speed throughout the journey? No. Sometimes vehicle is moving at the more speed. Sometimes you apply brakes, so speed of the vehicle decreases. When you press accelerator, speed increases. So if I ask you ki, at what speed you travels while going to your school from home, in that situation, what will you do? You will tell me the average speed of the journey. How do you find average speed? Average speed is defined as total distance traveled by the total time taken. Or you can say change in distance by change in time also. Let's say this is the initial point located at 0 meter. And this is the final point located at 100 meter. So change in distance is 100 meter divided by change in time taken. Now speed is a scalar quantity because we are referring to speed as 5 meter per second, 10 meter per second. We are not adding any direction in here. So we say speed is a scalar quantity and the units in which speeds can be measured is meter per second, kilometer per hour, miles per hour, knots, nautical miles, etc. But the SI unit is meter per second. But an important conversion that you need to keep in your mind is this kilometer per hour to meter per second and meter per second to kilometer per hour. So when an object is moving at some speed, let's say speed is given in kilometer per hour and you want to convert it into meter per second, then you will multiply the speed given in kilometer per hour by 5 by 18 and you will get your answer in meter per second. And for the conversion from meter per second to kilometer per hour, you will multiply it by 18 by 5. Now let's move on new topic, velocity. Consider this trolley A moving at the speed of 5 meter per second. There are 2 points, one toward right, that is point X at a distance of 100 meter, another point B at a distance of 100 meter towards left. Now, if trolley is moving at 5 meter per second, and if I ask you after 20 seconds, after 20 seconds, the trolley will reach whether point X or Y. Because after 20 seconds, if I want to find the distance covered. So distance covered will be speed into time. Speed is 5 into 20, that is 100 meter. So you can say trolley can either reach at point X, trolley can either reach at point Y. When I am referring to speed only. So sometimes if you want to be particular about the position that trolley should reach Y, the trolley should reach Y position, then you have to mention that the trolley must be moving towards its left at the speed of 5 meter per second. What does that mean? In some cases, you need to mention direction with speed. And when you mention direction along with speed, then that quantity become velocity. So velocity is nothing but speed with direction. And it is a vector quantity because we have mentioned direction also. Since speed we find as distance by time taken, because distance is a scalar quantity and speed is also scalar quantity. But velocity is a vector quantity. So instead of distance, we have to take displacement. Generally, in a straight line motion, magnitude of speed and velocity is same. But in some cases, magnitude of speed and velocity can be different also. We will consider this with this example now. Let's consider this path. Shape is square. Now from A to B, 10 meter distance, from B to C, 10 meter, C to D, 10 meter, and D to A, 10. Let's say person is moving along this boundary. And from A to B, he take 1 second. From B to C, C to D, and D to A, for covering all the four paths, person take 1 second. Now, if I have to find the speed from A to B, how can I find speed? From A to B, speed is defined as total distance by total time taken. Now, what is the total distance covered here? 10 meter. And time taken is 1 second. So, speed will be 10 meter per second. Now, if I talk about velocity, velocity is the displacement by time. And displacement is defined as the shortest distance or difference in the final position minus initial position. So, this distance is 10 meter only. This displacement is also 10 meter. So, velocity will also be 10 meter per second. Now, when person has reached from point A to C, he has covered the distance AB first, then from B to C, he covered again 10 meter. 10 plus 10, 20 meter in 2 seconds. So his speed is again 10 meter per second. But velocity is displacement by time. And displacement is shorter distance. So when person has reached position C from A, his shorter distance is this. It is 10 root 2 meter. So velocity will be 10 root 2 divided by 2, that is 5 into root 2 meter per second. So in first case, we have seen the velocity and speed have same value. But in this case, velocity is less than speed. Now third case, person started from A and again reached A. So what is the total distance covered? 40 meter and total time taken is 4 seconds. So again, speed is 40 by 4, 10 meter per second. But what about velocity? As I told you, velocity is displacement by time and displacement is final position minus initial position. Particle object, no, sorry. Person started from A, again reached A. So final and initial position are same. So this means displacement is zero here. So if displacement is zero, velocity will also be zero. Now, equation is given as speed is equal distance by time, but sometimes we need to rearrange the equations like this. The time is equal to distance by speed and distance is equal to speed into time. Okay, let's solve one question. An athlete completed 400-meter race in 2 minutes and 30 seconds. Calculate the speed of an athlete. Okay, we know that speed is given as distance upon time. Now, distance covered is 400-meter given. Time here, it is given 2 minutes and 30 seconds. So, we will convert whole time into seconds only. So, in 2 minutes, there will be 120 seconds plus these 30 seconds. So, total time taken will be 150 seconds. So, our speed will become 400 divided by 150, that is 2.7 meter per second. One more question we will solve. A spacecraft is orbiting around the Earth in an orbit at a height of 600 kilometer above the Earth's surface at a speed of 7 kilometer per second. Given radius of Earth is 6400 kilometer, find the time taken by the satellite to complete one oscillation. Okay. So we know that time taken is given as distance upon speed. Speed is given 7 kilometer per second. Now we have to find the distance taken. Okay. So let's say this is Earth of radius 6400 kilometer and this is the orbit in which that spacecraft is moving and the height of this orbit is 600 kilometer. When the spacecraft is orbiting in the circular path, in circular path, distance is given by circumference of the circular path. So distance will be given by circumference of the circular path divided by the speed. So time we will get. Now what is the circumference? Circumference is given as 2 pi r, where r is the radius of the circular path. Now when the spacecraft is orbiting in this orbit, so its radius will be this, that is 6400 plus 600, 7000 kilometer. Now in this question, we need not to convert from kilometer to meter because here speed is also given in kilometer per second and we will get our time value in second. So circumference will be 2 into pi into radius 700, sorry, 7000 kilometer divided by speed 7 kilometer per second. So in solving this, we will get 2 into pi into 7000 divided by 7. It will come to be 6280 seconds. Now, if you want to convert it into minutes, then you can divide this by 6280 divided by 60 and you will get 105 minutes. Now, how can we determine speed in laboratory? So, we can determine speed in laboratory using light gates. What are light gates? These are light gates. You can see this structure. From one end, infrared beam is being transmitted, and at this end it is being received. Okay, so these light gates are connected to the computers. So, and we have connected timer also, like when these are connected to the computer, and we have like programming is done, and whenever there will be interruption in the signal, timers are switched on and off. Now see, when we are using two light gates, how can we find? This is the trolley moving, and we will attach this peg. So when this peg will come here, it will interrupt the signal in this first light gate. So when this will interrupt the signal, timer will be switched on. Now timer is switched on. Now after covering this distance d, this trolley will reach this point. Now this time this peg will interrupt the signal for the second light gate. And when it will interrupt the second light gate, signal of the second light gate, programming is done in such a way that the now timer will be stopped. Now timer is switched on and switched off on the interruption of the signal. So we can note down the time and distance. This we know the distance between these two light gates, and we know speed is given as distance by time. We can find the speed using two light gates. We can find speed using one light gate also. How? For finding the speed using one light gate, we will use this interrupting card. We know the length of this interrupting card. Let's say it is D. And what we will do when this first part, when the starting of this card will enter here, it will interrupt the signal. And when it will interrupt the signal, timer will be switched on. So till the time the signal will be interrupted, timer will be switched on. And when this last end of the card will come out from this signal, so that time signal will be restored and the timer will be switched on. And we know the length of this card, and from timers we will know the time. Again, using formula speed is equal to distance by time, we can find the speed. Now there is a concept of relative speed. Consider a car A moving at speed of 15 meter per second towards right, car B moving at speed of 5 meter per second towards left, and distance between the two cars is 150 meter. Second situation, car A again moving at 15 meter per second again in the same direction, but car B moving at the same speed but in opposite direction. Means in first case, both cars are approaching each other, and in second case, both cars are moving in the same direction. Okay. Now distance covered is same. If I ask you in which case the cars will meet early, so you will say in first case cars will meet early. Now distance covered is same but time taken is less. And speed is defined as distance by time taken. Okay. Now here if distance is same and time taken is less, what does that mean? That speed in first case is more. Now we can see the magnitudes are same, but then how speed is more? So here the concept of relative speed is coming. So whenever two objects are moving in the opposite direction, then their speeds are added. So in first case, when two objects are moving, we say relative speed of A with respect to B. So it will become 15 plus 5, that is 20 meter per second. And in second case, when two objects are moving in the same direction, their speeds are subtracted. So 15 minus 5, it will become 10 meter per second. This means now A will approach the car B at the speed of 10 meter per second only. A with respect to B we are considering. Generally, we consider concept of relative speed only. Let's say I'm saying car is moving at the speed of 60 meter per second. So I say car is moving at the speed of 60 meter per second with respect to ground, and ground is always at rest. So generally, we don't mention that it is moving at with respect to ground, but it is with respect to ground only. When we draw distance time graph, what data we can get from the distance time graph? Let's say this is a distance time graph. If I plot, if I want to find the gradient of distance time graph, then gradient will be given as, we know that gradient is given as change in quantity along y-axis divided by change in quantity along x-axis. Now along y-axis here it is distance, and on y-axis, now on y-axis here it is distance, and on x-axis it is time. So gradient will be change in distance by time taken, and change in distance by time taken we have defined as speed. Therefore, gradient of a distance time graph gives speed. Now we will discuss different type of speed time graphs. Sorry, distance time graphs. First, when object is stationary, and we have to draw the distance time graph. So graph will be, when object is stationary, this means object is not changing its distance with respect to time. So graph will be parallel to time axis. Second is the object is moving at constant speed. Now speed is given by gradient of the distance time graph, and constant speed means constant gradient. Gradient is not changing. So it will be a straight line. Now it can be a straight line passing through a region if we consider initial distance as 0. It can be this also. Increasing speed, again, speed is given by gradient. Increasing speed means increasing gradient. So this graph will be for increasing speed. Decreasing speed means decreasing gradient. So this will be the graph for decreasing speed. Now here we will consider two graphs. Two graphs are given. So journey is divided into three portions. You can see A, B, and C. Okay. Now during the journey A, portion of the journey A, you can see a straight line graph. This means speed is constant, object is moving, or the particle is moving at the same speed, constant speed. Now from this point, you can see at 5 minutes, the slope of this is increasing or gradient is increasing, and gradient of distance time graph is speed. This means suddenly at this point, speed is increasing. At this point at 10 minutes, suddenly gradient became 0. This means particle came to rest. But you can see here sudden change in speed is taking place. So this journey will not be smooth. So practically what happens? Practically these type of graphs are seen. You can see slowly gradient is increasing, speed is increasing, then slowly it is decreasing. So it will be a smooth journey and it is practically taking place. How to solve a question? What type of questions will come? First question will come like this: ki a graph will be given to you and you will be asked describe the motion. Now from A to B, you can see the slope is increasing for distance time graph. And if slope is increasing, we can say describe her motion, uh, increasing speed. Okay. Now from B to C, we can see a straight line. So if it is a straight line, this means constant speed. Now from C to D, we can see the slope is decreasing with time. So we can say it is decreasing. This is one type of question. Now another type of question will come where you have to find the speed from the graph. How to find the speed from the graph? Now whenever you have to find the speed from distance time graph and the graph is a straight line, then you can take any 2 points on that straight line and find the gradient, you will get the speed. For example, from B to C, if I have to find the speed, from B to C, speed is constant. So we can take any 2 points on the line. So I am taking these two extreme points, one point this. So this point will be 350. And second point I am taking this point will be 70. And when speed distance is 350, time is 45 second, and when it is 70, time is 15. So gradient, we know that gradient is given as change in quantity along y-axis divided by change in quantity along x-axis. So change in quantity along y-axis means change in distance. What is the change in distance? 350 minus 70. It will be 350 minus 70 divided by change in x means change in time. That is 45 minus 15. So it will come to be 280 divided by 30. So 280 divided by 30, it will come to be 9.3 meter per second. So from B to C, the object is moving or the girl is moving or girl is riding her bicycle at a constant speed of 9.3 meter per second. Now we will learn how to find the speed if instead of straight line, a curved line is given. A curve is given. Let's see from A to B or from C to D, curve is given. Okay. So whenever curve is given, so what type of question will come? Let's say question is asked, find the speed, find speed at time t equal 7 seconds. So 7 second means this. So what you have to do, at 7 second, you will mark 1 point. Now, at this point, what you have to do, firstly, you will draw the tangent. Firstly, you will draw the tangent at that point. Tangent is a line touching the curve at 1 point. So how to draw the tangent? See, first of all, I will draw the tangent. like this. Keep ruler so that it should touch only one point, that single point only. See, let's say this. Let's draw a straight line here. Now on this tangent, you can take any 2 points and draw triangle. Any 2 points you can take. So let's say I'm taking these 2 points. First, one point I'm taking this, and second point I'm taking this. Now what I have to do, I have to draw this triangle here because I will use triangle method. Now I will find the gradient. So at this point, value of the distance is 110. At this point, value of the distance is 50. At this point, time is 32. Time is 32. At this point, time is 16. So gradient is again delta y by delta x, that is change in quantity along y axis by change along x axis. So it will be 110 minus 50. 110 minus 50 divided by 32 minus 16. So it will come out to be 110 minus 50, that is 60 divided by 16. So 60 divided by 16, it will come out to be 3.75 meter per second. So speed at point this 7 second is 3.75 meter per second. Okay. Now let's move on next. Okay. So next part is acceleration. Now, what is acceleration? So acceleration tell us about the rate at which speed is changing. As we were discussing, when you are going to your school from home, so your vehicle or your school bus is not moving at the same speed. Sometimes its speed is increasing, sometimes its speed is increasing. Let's say for first 10, it started from rest, that is 0 meter per second. Then after time 10 minutes, it reached the speed 20 meter per second. Again, after 10 minutes, it reached speed 10 meter per second. At point C, it is attaining the speed of 10 meter. At school, when it will reach the school, its speed will become 0. So you can see from here, in first 10 minutes, speed is increasing. In second portion from A to B, again, speed is increasing. In third portion, it is decreasing. So with time, speed is increasing or decreasing. So the rate at which speed is changing is known as acceleration. So acceleration is change in speed per unit time. Now, this change can be both positive and negative. So when speed will increase, we will say object accelerates. Like from H point to O or from A to B, speed is increasing. So we will say that object accelerates from A to B. And when speed decreases, we say object decelerate. As from B to C, speed is decreasing. So we will say object is decelerating. So acceleration is change in speed per unit time, that is delta V by delta t. How to find change in speed? Change in speed, we will find final speed minus initial speed. Final speed is denoted by V, initial by U. So V minus U by T will be acceleration. And acceleration is a vector quantity because it is involving delta V, that is change in velocity. Actually, see, here I am writing speed only. But in actual practice, acceleration is defined as change in velocity by time. So acceleration is always a vector quantity, but in our curriculum, we have to find the magnitudes only for acceleration. So therefore, we will be considering change in speed instead of change in velocity. But actually, acceleration is defined as change in velocity by time. So when we have to involve the direction, then we have to take velocities. So acceleration is a vector quantity and its SI unit is meter per second square. So from A to B, if I have to find acceleration from A to B, so when particle reach from A to B, final speed, that is 40. That minus initial speed, that is 20. Time taken is 10 minutes. If I convert it into seconds, so it will come to be 600 seconds. So it will come to be 20 by 600. So acceleration from A to B will be 20 divided by 600. That is 0.033 meter per second square. And from B to C, if I have to find the deceleration, it will come to be final speed is 10 minus 40 divided by 10 minutes means 600 seconds. So it will come to be minus 30 by 600. So it will be minus 30 by 600. So it will come out to be minus 0.05 meter per second. So now speed is decreasing. This means it is deceleration. And whenever there will be deceleration, there will be a negative sign. So deceleration is negative acceleration. Let's solve one question. A train initially moving at the speed of 15 meter per second. It speeds up to 39 meter per second in 120 second. Find the acceleration. Okay. So acceleration is defined as v minus u by t. V is final speed, u initial divided by t time taken. Final speed is 39 minus initial 15 divided by time taken, that is 120. So it will come out to be 39 minus 15, that is 39 minus 15, it will be 24. 39 minus 15, wait, 39 minus 15, 24 divided by 120. So it will come out to be 24 divided by 120, 0.2 meter per second. Now we will discuss different type of acceleration. What is constant acceleration, increasing acceleration, and decreasing acceleration. So let's consider this journey. So I have divided the journey from I to F into some parts. Okay. So when particle or any object is moving from I to A point. So what is the change in speed? Here I am mentioning speed and here I am mentioning time. This is speed and this is time. When particle reach from I to A, what is the change in speed taking place? Change is 10 minus 0, that is 10. And time taken is 10 seconds. So 10 by 10, it is 1 meter per second square. From A to B again, change in speed is 10 and time taken is 10. So again 1 meter per second square. From B to C, again 1 meter per second square. From C to F, again 1 meter per second square. We can see in each part, acceleration is remaining same. So we can say that it is object is moving at the constant acceleration. Speed is increasing, but the acceleration is constant. Now, what is increasing acceleration? Now you can see from I to A, when object reach, change in speed is 10 and time taken is 10 seconds. So acceleration is 1 meter per second square. But when object reach from A to B, change in speed is 30 minus 10, that is 20. 20 meter per second change in speed in 10 seconds. So acceleration is 2 meter per second square. From B to C, you can see change is 30 meter per second in 10 seconds. So it is 3 meter per second square. And from C to F, it is 100 minus 60, that is 14 10 seconds. So 4 meter per second square. Now we can see with the passage of time, acceleration is increasing. So we will say the object is moving with increasing acceleration. Decreasing acceleration. Okay. Now let's say initially speed is 0. At point A, it reached and its speed became 50 after 10 seconds. Means change in speed is 50 meter per second in 10 seconds. So acceleration is 5 meter per second square. When it reached B, change in speed is 40. 40 in 10 seconds means 4 meter per second square. Here from B to C, it is 30 in 10, so it will be 3 meter per second square. And from C to F, it is 20 meter per second in 10 seconds, so 2 meter per second square. Now you can see speed is increasing here, but acceleration is decreasing. So we will say the motion is with decreasing acceleration. Now we will talk about constant deceleration. So again, I have considered this situation. Here I am writing speed, here I am writing t, time. So from I to A, when object reached initial speed 50, then it became 40. So change is minus 10 in 10 seconds. So now here we are talking about deceleration because it is negative change. So it is minus 1 meter per second square. From A to B again, minus 1 meter per second square. From B to C again, minus 1 meter per second square. And from C to F again, minus 1 meter per second square. So we can see the deceleration is remaining constant. Now increasing deceleration. Increasing deceleration, we are considering initial speed is 100. From I to A, it reached, change in speed is minus 10 in 10 seconds. So deceleration is minus 1 meter per second square. But when it reached B from A, change is 70 minus 90, that is minus 20 in 10. So that is minus 2 meter per second square. From B to C, change is minus 30, so minus 3 meter per second square. And from C to F, it is minus 40 meter per second in 10. That is minus 4 meter per second square. We can see deceleration magnitude is increasing. So this is the journey of an object with increasing deceleration. Now decreasing deceleration, again, this is speed, this is time taken. So we can see from when object reached A from I, change is 40 meter per second in 10 seconds. So that is acceleration is deceleration is minus 4 meter per second square. When it reached B from A, change is 30 in 10 seconds. That is minus 3 meter per second square. From B to C, it is minus 2 meter per second square. And from C to F, it is minus 1 meter per second square. So we can see the magnitude is decreasing with time. So we will say the motion is with decreasing deceleration. Now we will talk about the speed time graphs. So when we draw a speed time graph and we want to find the gradient, so gradient will be change in y-axis by quantity along y-axis by change in quantity along x-axis. Along y-axis, we have considered speed. Along x-axis, we are considering time. So gradient will be change in speed by time. And change in speed by time, we have defined acceleration. So gradient of a speed time graph gives acceleration. And what about the area? So area, if we have to find, it will be speed into time. And we know that speed into time is distance. Therefore, area under speed time graph gives distance. Now we will draw different speed time graph. First, when object is moving at a constant speed, so this means with the passage of time, its speed is not changing. So its graph will be a straight line parallel to time axis. Constant acceleration, acceleration is given as gradient of speed time graph. So constant acceleration means gradient is remaining constant. So this will be the graph, this or this. Increasing acceleration, acceleration is given by gradient of the speed time graph. So increasing acceleration means increasing gradient. So increasing gradient means this. With the increase in time, gradient is increased. So this will be increasing acceleration and this will be decreasing acceleration. That gradient is decreasing with time. Now constant deceleration. So when it is constant deceleration, this means speed is decreasing with time. So graph will be this. Sorry, you can draw this graph. Increasing deceleration means speed is decreasing, but its gradient is increasing. So when speed is decreasing and its gradient is increasing, this means with the passage of time, you will draw this graph. Speed is decreasing and gradient is increasing. Decreasing deceleration means speed is decreasing, but its gradient is decreasing. So you will draw this graph. This will be graph for decreasing deceleration. Now we will solve one question. So this speed time graph is given. Calculate the distance between the start of the town and end of the town. So this point is the start of the town and this point is the end of the town. So we have to find the distance and we know that distance is given by area under the graph. So this means we have to find this area. Area under the graph means we have to find this area. Now for solving these type of questions, first of all, we will look at the shape of the graph. So what is the shape? This shape is rectangular. And we know that area of rectangle is given as area of rectangle is given as base length into height. Okay. Now make it sure if speed is in meter per second, here time should be in second. If time is given in minutes, then you have to convert it into second if speed is in meter per second. Unit should be same. Okay. So length, this length will be, so this point will be 42 and this point will be 18. So length will be 42 minus 18, 42 minus 18 and height. So this point is, so this point will be 11, 12, 12.5. This point is 12.5 minus 0 into 12.5. So 42 minus 18, it will come out to be 24. So 24 into 12.5. So 24 into 12.5, it will come to be 300. So what does that mean? The distance covered between the start and the end of the town is 300 meters. This is how you can use speed time graph to find the distance. Now, how to find the velocity using speed time graph? Now, if speed time graph is given and graph is a straight line. Let's say, if I ask what is the acceleration at time 10 second. So at time 10 second, first of all, we will check whether the graph is a straight line or not. So let me check with the help of this ruler. Okay. So I will keep the ruler. Wait. So if I keep the ruler here, so we can see this is a straight line. Clear? Till this point, it is a straight line. So this means कि from this point to this point till in this region, acceleration is constant. So if I ask you कि what is the acceleration at 10, so you can take any 2 points on the line and you can find the gradient for that. So let's say I'm taking these 2 points. I'm taking one point this and another point this. So at this point, we can see the speed is 16 and at this point it is 0. So acceleration is change in speed by change in time. It will be 16 minus 0 divided by time. 10 minus 0, it will come to be 16 by 10. That is 1.6 meter per second square. Now, if curve is given, let's say I ask you what is the speed at point time t is equal to 40. So speed at time t is equal to 40 seconds. Now, whenever curve is given and you have to find the speed, what you will do, first of all, you have to plot, you have to draw tangent at that point. So first of all, I will draw the tangent at that point. Okay. Now, tangent, as we have discussed in distance time graph also, it is a line that is touching the point, 1 point. So this is the tangent. Yeah, this will be the tangent. After that, you can take any 2 points on this tangent, and then you have to find let's say I'm considering these 2 points. Then you can use triangle method to find the gradient. So at this point, speed is 60. At this point, speed is 52. At this point, you can see time is 80. And at this point, time is 58. So speed will be again change. Sorry, I have to find acceleration here. Wait, let me correct. This is acceleration. And acceleration is again delta V by delta T. Delta V by delta T. Change in speed is 60 minus 52 divided by time taken is here time is 80 minus 58. So it will come out to be 60 minus 52, 8 divided by 80 minus 58, 22. So 8 divided by 22, it will come out to be 0.36. So it is 0.36 meter per second square. We can see the gradient is decreasing, so acceleration is decreasing. Now, if I ask you what is the acceleration at time 110 seconds, so you can see from 80 to 120, speed is remaining constant, velocity is remaining constant. So if velocity is remaining constant, this means delta V is, if velocity is constant, what does that mean? Velocity constant means change in velocity, that is delta V 0. And if delta V is 0, this implies acceleration is 0. So in this region, acceleration is 0. So this is all about chapter motion. Chapter is finished. I hope you will find this video helpful. And if you find this video helpful, share this video with your friends and subscribe to the channel so that you will get updates whenever I will upload the new video. And I am covering whole IGCSE physics on my YouTube channel in this series of videos. So share videos, like videos. If you have any queries, put your queries in the comment. If you want detail of any topic or any question related to the topic, you can put your queries in the comment box. Thanks for watching the video. Subscribe to the channel. Thanks.